On problem number 2, finding probability. Conditional probability is the probability that event will occur given that another event has already occurred. So basically kind of what that means is normally we have our whole denominator, right? 1,000 people for this two-way table, 1,000 people were surveyed or whatever. Yeah, it's a survey. So 1,000 people were normally surveyed. Well, when we have a conditional probability, that means it's shrinking our sample space. So our normal sample is 1,000, and what this conditional part does is it limits our sample space. So instead of looking at that total, we're going to look at any one of these totals. So we have a condition, and that condition, so the conditional part, that's this line right here, and usually sometimes that line can be defined in words, like when we read this. Okay, it can be defined in words, but what comes after the condition, what comes after that bar is our condition. So that's going to limit our sample space. Okay, so it's limited. Either I'm looking at this row or this row or this row, or I'm looking at this, or sorry, those are columns. This row, this row, this row. Okay, so that's our condition. So it shrinks our sample space. All right, so and this reads probability of B with the condition of A, or reads as the probability of event B given event A. So it's a condition. All right, so let's go ahead and read this. Here we have this bill that's happening. People are in favor of it or against it, and we have the different category of age versus who's a for and against it. Okay, so we're looking at what is the probability randomly selecting a person. So the randomly selected is always in there. You're going to see that randomly selecting person over 60. So we're selecting somebody over 60 years of age, given that, that's the key word that goes with this bar. So when you see the word given that, or who is, or who, or just given, that basically means this bar right here. So what follows those words is our condition. Okay, that's our A. So what follows that, that's our bar. What follows that, person had no opinion. So really we're only looking at everybody that had no opinion. So we're really just looking at this column. So that means our denominator is going to be 100. And now to the left of the bar, so to the left of the given that, that's what we're specifically looking for within that category of A. So that'd be a person over 60. So looking at over 60, and that'd be 40. It's hard to see there, but it's a 40. So 40 people out of 100. That's our probability. This is how would I write it? Probability. Maybe move that down. So it would be probability of over 60, given that we have no opinion. I believe that was correct. Yeah, no opinion. No opinion. That would equal 40 over 100, or 0.4, or 40%. Okay, and so that's how you do it. So what follows given that, that's the condition. Okay, what's before that is what we're specifically looking for. Okay, so go ahead and try this. We're dealing with the same numbers here, and here's the question right here, right? Always look for the question mark and then read before that. Okay, so here you have the same chart there, if you can see it. There you go. Okay, so go ahead and try that one on your own.